Lesson 5-3, polynomial functions. So by the time we're done with this lesson, we should be able to classify polynomials both by the degree and the number of terms. We're also going to talk about how to evaluate polynomial functions and then identify general shapes of graphs of polynomial functions. Okay. So to start with, we are going to define a polynomial in one variable. Okay, so a polynomial in one variable is an expression in the form of, and then we have this general equation here, where a sub n can't be 0. So that's just talking about this first term. That can't be a 0, because if this number in front is a 0, then this term would go away. So it would simplify down, and then we would start with this term. The a's, so the a sub n minus 1, the a sub 2, a sub 1, a sub 0. So again, those are just numbers, and we're putting subscripts with them to show that they can be different numbers. Okay. And they have to be a real number, so they can't be imaginary. And n, so that's the power on all of those, is a non-negative integer. Okay, so it has to be a whole number, and it cannot be negative. And also, like the name suggests, if it's a polynomial in one variable, we can only have one variable in the equation. So if we have an x and a y, that's no longer a polynomial in one variable. Okay? And all polynomial functions are continuous. So that means if I draw it on a piece of paper, I can trace along it with your pencil, and you're never going to pick up your pencil. Okay, so all polynomial functions are continuous. The leading coefficient, so I'm going to abbreviate that as LC, is the number in front of the first term. And we have to be careful, so when we're talking about that, we're assuming that our polynomial is in standard form. So the leading coefficient, another way to think of it, is the number in front of the term with the highest exponent, or the highest power. Okay? So that's where our leading coefficient is going to be. Now as we get into classifying, we're going to start by classifying by degree. So I've set up this little table here. So we're going to use this to classify by degree. Okay. So if we have a 0 degree, so our x value isn't even there, we're going to call that a constant. Okay. So we would see something like f of x equals 3. Or we could have something like f of x equals negative 12. So all of those would be examples of a constant when we don't even have a variable in the equation. If we have a degree of 1, this is our linear equations. Okay, so again, we could have something like f of x equals x plus 2, or we could have something like g of x equals 2/3 x minus 1. Degree of 2, that's a quadratic. Okay. So again, an example of that would be something like f of x equals 3x squared minus 5x plus 4. Okay, so the highest power is the 2, so that's how we classify it as a quadratic. If the highest degree is 3, we call that a cubic. Okay. So something like f of x equals negative 4x cubed plus x squared minus 3x minus 5. Okay. And if our highest power is 4, that is a quartic equation. Okay. So f of x equals 3x to the 4th minus 1 could be an example. So we can have other terms in here, but we don't have to. And let's see. The 5th degree, this is a quintic. Okay. So again, the highest degree has to be a 5. So we could have something like f of x equals negative x to the 5th plus 6x to the 4th as an example of that. And anything above that, they do have names, but they're not very well known. So we would just say that it's a 6th degree polynomial. okay, or 7th degree or 8th degree or whatever the degree happens to be. And sometimes even with these two, we'll say it's a 4th degree or a 5th degree, but these vocabulary terms are used a lot more than the other ones because they're more common. Okay? And again, we could have something like 4x to the 6th minus 2x squared plus x plus 10. So that would be one example of a 6th degree polynomial. Now I have this other column here called the leading coefficient column. And I'm going to actually split this one more time. Okay, and I'm going to put term here. Okay. So the leading coefficient, again, is the number in front of the highest power. So if we take a look at the first example for all of these, so this one, our leading coefficient, so we are assuming that this is just x to the 0 here, would be 3. Okay. And again, if there's not a number there, we assume that it's a 1. So our leading coefficient would be 1 for this one. Or on our g of x equation, it would be the 2/3 for the leading coefficient. For this one, again, this is our highest power, so our leading coefficient is 3. Here, the leading one is -4. We have 3 again for our leading coefficient. This is a -1. And here we have a 4 for the leading coefficient. Now, we can also classify by the number of terms. So that's what this column is for. So classify by number of terms. Okay? Now, a term is separated by a plus or a minus sign. So if we have a monomial, that's 1 term. If we have a binomial, that's 2 terms. A trinomial is 3 terms. Anything more than that, we would just say it's a polynomial of 4 terms or 5 terms or however many terms there happen to be. Okay? So if we go back and look, a constant is always going to be a monomial. So I'm going to put M for monomial. Linear, so here we have 1, 2 terms. So this one is a binomial. This is also a binomial. So I'm going to put B for binomial. Here we have 1, 2, 3 terms, so this is a trinomial. So T for trinomial, since I don't have a lot of space to write. Here we have 1, 2, 3, 4. So this one we would say is a poly of 4 terms. Next one we have 1, 2, so that's a binomial. The last one, the quintic, again we have 2, so this is also a binomial. And the last one we have 1, 2, 3, 4 terms. So this would be a polynomial of 4. So in the next video we're going to do some more examples of classifying by both degree and number of terms, as well as write things in standard form.